Hi folks, this is Coach Luke of Team 30329 Mechanical Masterminds, and today I want to do a tutorial of designing a parallel plate drivetrain in Onshape. So this is the drivetrain that we're going to be designing. It is following a tutorial from Tristan on YouTube that we found really helpful on my team, but I wanted to make it a little more accessible, a little easier to follow than his tutorial, and I updated a few parts. But shout out to Tristan because we learned an awful lot from that. So let's get into building this parallel plate drivetrain from scratch. So I'm going to first create a new Onshape document and give it a name. And let's get right into drawing. So we're going to start by making a sketch, and I'll sketch on the front plane here. I'm going to look right at the front plane, which makes it a little easier to sketch. And I'm going to start by drawing a couple circles that represent the wheels and the motors. So these will act as guides for the rest of the sketch. One of the great things about Onshape is you don't have to be careful how you draw things to begin with, then you can dimension them after the fact. So let's go and do that. Let's make this the size of one of the 104 millimeter mecanum wheels that we're going to use. So that's 104 millimeters. We're drawing in millimeter units here. And now to make the other one match this one, we can do another Onshape shortcut. Select both of the wheels, and then we can use a equals constraint. So now the second wheel is set to equal to the size of the first wheel. And now we want to line them up as well. So let's select the center of both wheels, and we will give them a vertical constraint. Or I'm sorry, a horizontal constraint. So that sets them to the same height. So now if I move one, the other one moves with it. And if I change the size of one, of the first one, let's say I decide to use a different size wheel, because their equal constraint is applied as well, both of them change. So let's go back to 104 millimeters. Now we want these to be even with the bottom plane. So let's set a distance between the circle here and the bottom line of 0. Okay, so now the distance, the vertical distance between this plane and the wheels is 0 millimeters. All right, now I'm going to draw a couple circles that are going to represent the motors, and we'll start positioning them as well. Okay, so let's set the size of this to diameter to 37.5. This is going to be a yellow jacket motor from GoBuilda, and that's the size of the motor, or actually it's a little bit smaller than that, but that gives you a little clearance. And then we'll do a shortcut here. I'm going to hit escape to get out of that dimension tool. Select both of them, and now I want to set them both on the same horizontal plane. So I'm going to, select the center points, not the circles. And then instead of clicking the horizontal up here, you see when I roll over it, it gives you a shortcut, which is the H in parentheses. So I'm going to type H instead of clicking it. It's a lot faster once you learn some of these shortcuts. Now I'm going to select both of them, and instead of clicking equals up here in the toolbar, I'm going to just type E and make them the same size. That's really great. Helps a lot with doing things quickly in Onshape. All right. So now I'm going to set a distance between the center of this motor and the center of this wheel. And that is going to be 140 millimeters. Okay. I'm going to set a distance from the center of this wheel to the center of this motor of 77.7 millimeters. And I need to define the distance between these two motors. So we'll set the height above this horizontal line to 22.75, and we'll set this distance to 41.4 between the two motors. Okay, so this is just a guideline sketch. We're going to build some other sketches off of this. But that shows you the roughly the outline of the motors, where they go, and the outline of the wheels, where the wheels go. All right, so then let's move this to the center here. So let's draw a construction line between the two wheels. And let's change it to a construction line using this here, or you can use the shortcut Q. Construction line. So now it's dotted. I'm drawing a point here, and it snaps to the middle of the line when I hover over it. Now I'll draw another construction line. Vertical this time. And I don't care too much about the length of that one. Now I'm going to set a constraint between this midpoint and this line. I'm going to set a vertical constraint, so I'll type V or hit this. Vertical with 2 points, V. Okay, so now this is all centered around this vertical axis, and the wheels are sitting on the horizontal axis, which is equivalent to the ground. Let's change the name of this sketch to Guide Sketch. Okay, so that shows up here. And we'll exit this sketch, and we'll start a new sketch. And we'll call this one Inner Plate Sketch. This is going to be our inner plate. We're going to draw on the same front plane that we drew the last sketch on. Sketch plane. There we go. Center point rectangle. So this is going to be a rectangle centered with the same around the same place that the wheels are centered. We'll give it some dimensions. We'll make it 381 millimeters long and 71.6 tall. Okay, so now I actually see my motors are sticking out below my plate here, which I don't want. So I'm going to go back to my guide sketch, and I'm going to move those up. So right now this is 22.75. Let's change that to 32.75. And then we'll go back into our inner plate sketch and see how that looks. Okay, and it's still sticking out a little bit here, so let's adjust that a little bit more. Go back to our guide sketch. We'll go to 30. Let's do 37.25. Go back to our inner plate sketch. Okay, and let's just see how far away that is from the bottom of the plate. It's 2.3. I'd like to have that a little bit more. Let's go 4.5. Okay. I think I'm happy with that. So let's start adding some holes for axles here. We're going to do 4mm holes. That's the standard hole size for Gobilda. Let's do 4 holes at the corners for spacers to hold the plates apart. Doesn't matter if these are the same size. We're going to go and fix that in a second. And it doesn't matter if they're lined up. We're going to fix that in a second too. Set some constraints. So we'll exit our circle tool and select all 4 of the circles here. And I'm going to hit E to make them all the same. But I must have had a point selected. Circle selected, circle selected, circle, and now E sets them all to the same size, and I defined this one as 4mm. Just double check that. Yep, 4mm. Well, not exactly actually. Let's set it exactly to 4mm. Now we'll select the points. And I'll hit V to make those vertically aligned. And I'll do the same thing on this side. Select these 2 points, V to vertically align them. Now I'll select the top 2 and horizontally align them. So I'll hit H to horizontally align those. And then with the bottom ones, I'll select those 2 center points and hit H to horizontally align those also. And now I need to tell it how far from the edge I want those to be, those spacer holes to be. So let's set that to, let's see, set that to 4 and 4. And then we just need to set that vertical one to 4. The horizontal one's already set from the other guy, the other hole at the top. I can show you. That's telling me it's over constrained. I tried to apply too many constraints. So let me delete that. Sketch could not be solved. So I'll delete that constraint that I just put on, and it's all happy again. Now I'll set this distance to 4mm. The height is already set. And you'll notice also that things turn black in Onshape when they're fully constrained. So this line, for instance, is perfectly fully defined in space, but this line is not yet. We need a couple of through holes for the motor mounts. Or for the motors rather. The motors are going to stick through here, and we want this to be close to the motor size. We're going to go with 36.5 diameter, and we're using the same center point for the motor. 36.5 diameter. Now we need a couple more through holes here. So let's set one. And that's 4 millimeters. Distance from the center of the circle to the edge here is also going to be 4 millimeters. And let's make a couple more here. Put a spacer down here. 4 millimeter diameter. Distance to the edge is going to be 4 millimeters. Put a couple in here. 4 millimeters and 4 millimeters. And we're going to line those ones up vertically. So we'll select the center point and type V to line them up vertically. We'll set the distance between these two to 32 millimeters. And we'll set the distance from the bottom one to the bottom of the wheels to 30 millimeters. And then I want to center this one between these guys. So let's draw a couple construction lines. And we'll do one line here and then one line here. And what we're going to do is select both of those lines. So escape to get out of my line tool so I can select them. I'm going to set them equal. So you see now they're the equal length. And I'm also going to make them both construction lines. So I'm going to switch them to construction, which you can use Q to do that too. Okay, and there's a few more through holes that we need to draw here for spacers. Around the motor mounts, we're going to put 4 spacers. So let's draw those. I don't want it as a construction line. I want it as a real line. Let's set the size of this to 4 millimeters. And let's set the distance to from that to this guy 2.5 millimeters. So I guess we'll draw a couple more construction lines here so that we can make a mirror line. One between here and here. And we'll do a midpoint line here, so it starts right at the middle of the motors. There. All right, and so we'll go back to our mirror tool and select a mirror line. We'll mirror around this. So you see it made another copy, exactly the same distance. And then we'll exit the mirror tool and re-enter to create a new mirror about this line now. And select entities to be mirrored. We're going to select both circles here. So now we have a 4-hole pattern around our mirrors. And I like that. So now these are all not fully constrained yet. If you can see, if I grab one, I can move it and the others move too. They keep mirrored about the center line, but I haven't defined exactly where the first one should be. So they can all move together. So let's do that now. Let's set the distance between these two holes. The go build a pattern, the distance here is not super important, but the go build a pattern is multiples of 8 millimeters. So let's set this to 24 millimeters. That's a good round number. Let's round these corners so they're not so sharp. So let's create a fillet here between these two lines. And we can change that radius if we want. increase it or decrease it. Let's go with a radius of 4. Radius 4. Yep, that's fine. And then do the same thing on this side. Okay, so at this point we can exit our sketch and now we can make our first plate. So let's do an extrude, and we're going to extrude the faces of the inner plate sketch, which is what we were just drawing. We're going to extrude it by 3.175 millimeters, which is about 1/8 of an inch, which is a standard thickness for aluminum plates and such. So there is our first plate. So let's just check one thing here. We want this plate to go away from this, from the front, from the sketch. So let's open back up our extrude, and it's actually coming towards the front from the sketch. So we're going to change directions here. That's going to be important for spacing between our plates. So 3.175 millimeters, but we want to extrude it backwards, not forwards. This little arrow tells you which direction it's going. Be done with our sketch there. We'll go back to the front view and we'll start a new sketch. But first we need to define a new plane that what we're going to draw next is going to be the front plate, the outer plate. And so I'm going to create a new plane based on this front plane and an offset. So I'm going to make it 56 millimeters away from the front plane. And let's see which direction it's going. Right now it's going towards us, which is what we want. You can change direction if you want that way, but we want it in front by 56 millimeters. That's the length of the spacers in between the two plates. So I'll hit OK on the front plane. Now we're going to create a new sketch. No, not a new extrude, a new sketch on this plane 1 that we just created. And let's call this one outer plate sketch. To the front view, see everything right on, and center point rectangle, and we will set the center to this point with coincident, which is also I as the shortcut. Okay, so now it's got the same center point as the inner plate rather, and set this line and this line to coincident as well, and this line and this line to coincident as well, which is I. So, oops, it didn't like that. I haven't defined this. Oh, I defined the center point, but doesn't like that. Control Z. All right, let's set this lines. Undo this center point constraint here. And now I think we can set this one to coincident. Oh, still no. Delete that center point constraint. There we go. Now it's coincident with that line. We'll do the same thing with these end lines. We're still in coincident mode. So just selecting these two end lines. Okay, and we're fully constrained now. And for the outer plate, we need the same axle holes that we had on the inner plate. And we need the same spacer holes that we had on the inner plate, except we don't need these spacer holes around the motor mounts. Those are not going to go through the outer plate. So let's draw these guys. And we will set them all equal to the same width in a minute, or same diameter in a minute. Okay, so let's exit our circle tool. You can hit escape to exit the tool. And we will go select all of these circles, set them all to 4 millimeters at the same time. I'm going to set them all equal first, and then I'm going to dimension one of them. Dimension this first one here as 4 millimeters, and you see they all resized. All right, and now we need to go and make them coincident with the ones with the circles behind them. So let's get out of our dimension tool with escape. And let's select the center point and the other circle, and let's do concentric this time. That way you can select a circle and a point, or two circles, and it'll line up the centers of the two circles. So concentric is Shift-O is the keyboard shortcut. So we'll just do that for all of these. You can select either the circle or the center point for concentric. Shift-O to snap them. Shift-O. Shift-O. Doesn't matter if you select the center point or the actual circle for the concentric command, which makes it super easy. Shift-O. And this can be two circles of different sizes for the concentric command as well. And the other thing we need on this outer plate is we need smaller holes for the motor shafts that are going to be concentric with the larger holes for the motors on the inner plate. So let's exit our circle command and let's make that concentric with this. And same thing here. Shift-O to make them concentric. Let's make them equal. Select both of them and type E to make them equal. This whole diameter we're going to make 14 millimeters. So let's give that a dimension. Okay, so that's smaller than the motor, but bigger than the motor shaft, so there's plenty of room for it to spin. And the last thing here is filleting these corners. And it's defaulting to R4, or you can type in 4 millimeters and hit OK. And if you want to just touch one thing, you can touch the point instead of selecting both lines, and it'll fill it that just fine. All right, so we're finished with that sketch now. So we can go ahead and extrude that sketch. So we'll select outer plate sketch, and extrude. And let's check the direction. I want it to move away from the inner plate so that our 56mm spacing stays correct. And we're going to again go with 3.175mm. Okay, so that is our starting point for our outer plate. We're not quite finished with it yet. There's one more thing we're going to do. If we look at it from the front, let's make a new sketch. What we're going to do is do some pocketing on this front plate. I'm going to change this to pocketing sketch. I'm going to select plane 1 as my sketch plane, the same one that I drew the outer plate on. Now I'm going to start to draw my lines. I'm going to try and snap it to the center of each circle automatically so I don't have to go back and do that again. And I'm basically going to connect all the centers of all these circles together. But there's some flexibility in exactly how you want to do this. And we'll go back and refine a little bit probably. Somewhere like that. And we'll do something like this. And maybe also like that. And like that. We don't have one connecting the bottom too. Let's see. Put one there. And let's put another one here. And then actually let's move this up. Oops. Undo. Grab that point. Oh, it's locked. It's got these constraints. So I'm going to delete that constraint. Select and then hit the delete key. Now I can move the point up to this line, move this point up to this line. Same thing here, select the constraint, delete, select the point first, then select the constraint, then hit the delete key. And I can move this up to here. Say I don't want it to be perpendicular or intersecting. Maybe I want these to be equal length, so I'll select 1 and then 2 and then type E to make them equal. Same thing here, equal, equal, equal. And now let's put another line here and here. And okay. Let's try that and see how that goes. Okay, so now we're going to use that sketch, the pocketing sketch, to make this front plate lighter by taking some of the material out. So we're going to use a custom tool called Lighten. You can add this as a custom feature by selecting Add Custom Features, do a search for Lighten, and this feature script Lighten copy is the one that I picked, this one that comes up at the top. There's a lot of these available. Then you're going to select the little caret here and select Lighten. From Faces to Remove, we're going to select the pocketing sketch. And then Parts to Lighten, we will select Extrude to. Then we can change. You can see that it is basically, started to cut away all the material in between. We can change the thickness of the walls and change the radius of the corners, which they call the tool radius. Let's go a little thicker than this. Let's set, maybe 4 millimeter. Then the cut depth doesn't matter that much. You can do through all, and that works fine. Or you can give it an actual depth and hit OK. So that looks pretty cool, doesn't it? Now looking at this front plate, I think there's one or two things I want to change. These two holes here are for mounting a channel on the back plate, so I actually don't need those on the front plate. So I can get rid of those. And then also, I don't think I have enough spacers. Let's put another spacer on the bottom, and so we have 4 along the bottom, and let's add another spacer on the top as well, so that we have 4 on the top. So let's go back to our outer plate sketch now here, and we'll just delete these 2 unnecessary holes that don't need to go through the front plate. And then for the spacers along the top and the bottom, let's go ahead and add another spacer here. We'll make it 4 millimeters like all of our spacers are. And another one here. We'll make it 4 millimeters. Let's line those 2 up vertically. So I'm going to exit my circle tool, select both of the center points, and hit V to align them vertically. And then I'll align the bottom one with this by typing H, and I'll align the top one with typing H. And then let's go ahead and set the spacing here. Let's take a look at what we got. So we got 111.3 for the right one. That's already defined at that 111.3. Let's give that 111.3 also. We'll draw another one, and so I don't have to go and constrain it. I can mouse over the center point of this one and then start to move up, and you see it already has it defined as vertical from the lower one. So I'll go 4 millimeters, select the center point, align it horizontal with the others. Okay, and then I want to modify my pocketing sketch a little bit because I moved a couple things around. So let's take this point and move it concentric with that, and maybe bring this point down. Delete that point right there. Let's see. I want to maybe delete this line. Take this point and stretch it down to here. And now I need to connect to this hole. Delete that constraint and stretch this point to this hole. Cool. So we didn't even have to do anything other than move the points around, and it regenerated our pocketing for us. Okay, and now we're going to go ahead and make a third plate, which will be our motor mount that's going to sit in between these 2 plates. That's going to support the other side of the motor and the motor bearings. So we're going to make a new plane first. Plane off of the front plane here. And we're going to define it by an offset. And the offset this time is going to be 32 millimeters. And we can check that it's creating it in the correct direction. It should be between 2 plates that we have here. So that's correct. And we'll make a new sketch on plane 2. And let's look at the front. First of all, start drawing to correspond with our holes here for spacers. And I'll set this concentric with the existing hole because we want that spacer to line up. And I'll set the dimension to 4 millimeters. All right, and now instead of recreating that, let's copy and paste it. So Control C to copy and then Control V to paste. And then let's set this one to concentric. So Shift O with that. And then I can now copy both of these, select both of them, Control C, Control V, select both of them, and drag them over. And then set this one concentric with this guy, and then this one concentric with this guy. All right, now we're going to draw the circles for the motor mounts. These are going to be, again, 14 millimeters and 14 millimeters. And let's set that, escape out of the circle tool and set it concentric, Shift O with the existing one. Okay. Screw holes around each of these motor mounts that line up with the screw holes on the motor. So the motor is going to have to screw to these motor mounts. Actually change the name of this to motor mount sketch. And now we'll go back and do our linear pattern here. I'm going to set this to 16 millimeters, and then the vertical I'm going to set to I have to change this to only 2 copies in the X direction. I had to leave the sketch to get it to accept. Normally there should be a window that pops up here that you can hit the green check mark, but it's not showing up for some reason. It doesn't want to let me do that. So I'll just set a dimension here. That should be 8 millimeters, and this should be 8 millimeters as well. That will center it. And now I want to transform them. Go back into the motor mount sketch. It took me out somehow. Dimension here to here is 8. Let's go ahead and set these two to vertically aligned, these two to vertically aligned, these two to horizontally aligned, these two to horizontally aligned. And now let's move these to where they're supposed to be and dimension them correctly. So dimension center to this guy should be 8, and that to that should be 8. Okay, so they're vertically dimensioned correctly now. That to that should be 8, and they're horizontally dimensioned correctly now. All right, so now we're going to add the exterior of our motor mount plate. We'll just draw it as a rectangle to begin with, and then we'll start adding some dimensions. We'll go from this center point to this line. We'll call that 4 millimeters. And we'll go from this center point to this line. We'll call that 4 millimeters. And same thing in this opposite corner. 4 millimeters and 4 millimeters. So we can leave the sketch, and then we're going to select the sketch and use the extrude function. And I want it to go towards the front, and it is going towards the front. Let's make it like 4 millimeters. And we'll hit OK. Fill it while it is a plate, and we'll fill it to 4 millimeters again. So we're going to select each of these corners to fill it. Corner edges now. Okay. And we're going to do one more. We're going to chamfer now. We're going to chamfer these screw holes. Let's chamfer them to 4 millimeters as well. This is basically going to give us maybe 3 millimeters. That looks pretty aggressive. This is going to give us essentially a countersink for our screw heads on this motor mount. So I can chamfer all of these at the same time. So look good. Let's see what does it look like if we go to 2 millimeters. 2 millimeters might not be enough. Let's do 2.5. Okay. So now our motor mount plate is done. So now that we have all 3 plates here done, the inner plate, the outer plate, and the motor mount plate, the next thing we're going to do is we're going to create a assembly for the left side. First of all, let's rename this part studio as left side plates. And now we'll go in assembly mode. We'll rename this left side assembly. And we're going to insert our left side plates here. Okay. And now we're going to start to bring in some off-the-shelf parts. So we'll go to Other Documents, and we go to our home. We have this FTC Robotics Parts Users Library, and we'll go into the Go Builda, and then Motion, and let's add wheels. Mecanum wheels, the Grip Force 104 Mecanum wheel. We'll go to assembly. All right, so we're going to need one left slant. Insert that. And one right slant. So we'll insert that. Okay. And then let's move this stuff around here. All right, so if this is the left side of the assembly, then this one's going to go in the front, and this right slant is going to go in the back. Then we're going to insert some more off-the-shelf parts from Go Builda. We'll insert back. Forget if it's in hardware or structure. Let's see. Let's go to structure, standoffs and spacers. M4 standoffs, we want 1501 series M4 by 0.7, and we need a 56 millimeter length. 56 millimeter length. So let's insert that. And then we need the same thing, but 32 millimeter length. The 56 millimeter length is going to be to hold the two main plates, the inner and the outer plate, at the right distance. And then the 32 millimeter length is to connect the motor mount plate to the inner plate. Then we need some shafts. Beams, nope. Maybe it's in motion. Shafting and tubing. So we want stainless steel rect shafting, 8 millimeter diameter, 2106 stainless steel rect shafting is what we want. And we're going to take the same 56 millimeter length. There it is, 56 millimeter length. We'll grab that part. Okay, now we can start putting things together. Okay, so let's start fastening our things together. So we'll start with a fastened mate here for this axle. And I'm going to select roll over until we get all the dots like this, and then hold shift and select the very center. And then we'll go over here and roll over that circle. We get the center. It's sticking out the back, not the front. So we will flip the primary axis and then hit OK. And now we could copy and paste that, but this is a little faster. We'll do replicate, and we'll replicate this instance. We're going to replicate the fasten match, and we're going to match individual edges. And we'll select this edge, and bada boom, bada bing, it replicated. Now, to keep these two plates from flying apart, let's go ahead and also fasten the front. So we'll do this. Let's hide that front part for a second. Okay. Now let's show that. And for a second. Then we'll show it again. And accept. Okay, so these the front piece and the back piece are now held together by the axles. Now let's go ahead and put our spacers in. And we'll use fastened mates for these two. And there's a guess that works. And then we'll pick this here. Flip the primary axis so that it is pointing the right way, and hit OK. And now we're going to do replicate again. Match edges on face, we'll put that same spacer in every one of the holes on this face. That's the same size. And actually we don't want that. We have some here in the middle that are supposed to be shorter spacers. So we'll still have to do it individual edges. But this makes fastening a lot quicker. So it's definitely very helpful. And I see we're missing a couple of through holes on the back side here. We'll have to go back and fix that. But first, let's get the short fasteners in, or short spacers in. You're doing that the same way. Selected the wrong face of that. I want it on this front face. Okay. Now let's replicate this one. There we go. Okay, we got a hanging washer here that I don't think we need right now, so we'll get rid of that. All right, so we got all of our spacers in. We got a couple of misplaced spacers here. We don't need a spacer in this hole. So we're going to want to just delete one of these. And then also that one. Okay. Yeah. So we're missing a back hole here. Missing a hole on the back plate 1, 2, and 3. Those extra holes that we added to the front plate, we're going to have to add those back to the back plate. All right, so let's go back to the back plate and fix that. Let's just make a new sketch here. And create a new sketch. Select a sketch plane. We'll select the front plane for this one. Create a couple circles here. And there. And then there. Those 3 that don't go all the way through. Let's make these coincident or concentric. So exit my circle tool, select that, and select this hole and make it concentric. So that's in the same whole plate, just the hole, concentric, and concentric. And then we will extrude this through the back plate. So we're going to remove in our extrude, and we'll go through all. Now we can go back to our assembly and fill in our missing spacers here. So let's replicate this. Sorry, gotta reselect replicate with nothing selected. Faces, instances, replicate that one, match individual edges. We'll put one there, and we'll put one there, and we'll put one here. All right, so now we have all of our spacers in place. Looking good. Okay, so now we're going to insert our pulley that will attach to our wheel and let our wheel spin with the belt that is also going to wrap around a pulley on the motor. So the way we're going to do that, we have a part studio in our library that generates pulleys, and so we need to use we need to create a new part studio here. We will create a derived part studio part. And we'll look in other documents owned by me, pulley gen with mods copy. So we can select the color. We'll just leave it as green. We're going to use 5mm HTD profile. That's the size of the teeth. We're going to use 24 teeth on the pulley. Our belt width is 9mm. These other parameters, we can leave the rest of these as they are. And we'll hit generate. And that will insert for us right there. Accept that. Let's look at it from the top. All right, now we're gonna add on to this a bit of a mounting plate that we can use to attach it to the robot, or to the wheel rather. So we're going to create a new sketch for the mounting plate. We'll use the same top sketch plane. And we'll start by drawing some circles here. This is going to be the go build a sketch pattern again. And so the distance here, those will be 32 apart. And 32 apart that way as well. Set those two to vertically aligned. Set these two to vertically aligned. Set those two to horizontally aligned, and these two to horizontally aligned. And finally, we need to set the diameter of these guys. So it's going to be 4mm diameter again. And we're going to set all of these equal to each other. Select each of these circles, all 4 of them. And E sets them all to the same size. Now the last thing we need to do is center all of these on this center of the pulley here. So if this is 32, this is the full distance between the two, then the vertical distance for the top holes should be 16, and the horizontal distance should be 16. Cool. All right, and then we need to create the rest of this. So we're going to do a center point arc. So we select the center of this circle, and we want it to go from 90 degrees to 180 degrees, or I'm sorry, to 90 to 180. And we'll set the radius of this 4. Then we'll do line that comes in a bit here. So we're going to do another center point arc here as a construction line. Started at this hole, go to the center of that hole, and we're going to select it and turn it into a construction line. There. It says it's got too many constraints. Not sure which constraint it doesn't like, but let's delete that one. And then we're going to draw a point right at the center of this construction line. We'll use that point to do another center point arc, starting from here now. Center point arc starting from that midpoint, and we'll go from the end of that line to the x-axis here. Then we will set that radius there we go, 4. All right, and now we're going to create a couple tangent constraints here. I'm going to make these 2 lines tangent, and I'm going to make these 2 lines tangent. Sketch cannot be solved. Undo that. Let's do this one first. Tangent here. There we go. And then this one, probably I need to delete a constraint here. So I'll check that. Constraint here, I'm going to delete that constraint. The horizontal constraint. Now I can drag that up and down. Let's make this tangent with that. Good, so it's a nice smooth line. Now we're going to select both of those lines. Oh, this one I want to set a horizontal constraint with the center point here. There we go. All right. Select a mirror line, horizontal axis, select entities to be mirrored. So we'll do that one, and that one. Okay, there we go. So now we can create a circular pattern. Let's do that here. Select all of our lines. And we want to do it 4 copies. Okay. Accept that. That doesn't quite match. Just stretch that to match. Now it's fully defined, except I got an extra curve there. Okay. Good. And then we can, we need a through hole in the center of this too. And then we can extrude that sketch. We want to do it off of this back surface. So starting offset is going to be 6 millimeters. And we're going to extrude it to a depth of 12.5. Accept that. All right, so we're going to make a new sketch, and we're going to basically make countersinks for these screws. For the sketch plane, we're going to we'll select this top surface of the spacer, and we'll draw some circles. That are actually, let's redo that. Delete that. Okay, that looks better. So we're going to make our circles from the center point to the top point. We will extrude that, and we're going to do solid remove. We're going to remove blind. We're going to go 4 millimeters. Extruding sketch 2. So we're going 4 millimeters into the part. We also want to come back up. So we'll go symmetric. Then actually, I guess we'll go 8 millimeters. It's going to extrude up and down. We'll do this as 2 different extrudes. We'll go down by 4 millimeters. Okay. Let's see a little bit of leftover here, so let's clean that up. Go back in our sketch. And let's edit this one. I'm going to delete that constraint, and we'll give it a radius of 8. Let's do that for all of them. Delete this constraint and give it a radius of 8. All slightly different, so we're making them all the same, and make them go slightly past the edge so that we don't end up with that tiny little sliver. Okay, all right, good. And then now we need to remove this material above as well, so I'm going to take this same sketch and extrude it again. Remove, but now we're going to go in the opposite direction. We're going to go up, and we'll go through all. So now we've got nice little cutouts for the screw heads. All right, a couple things left to do to clean this part up. We're going to fillet some corners and things. So let's get our fillet tool here. 2 millimeters may still be too much. Let's go to 1 millimeter. And we're going to chamfer here. That edge right there. There we go. That's what I'm looking for. And maybe 1.5. Doesn't need to be quite so thick. That looks pretty good. And then let's fillet these edges here. Okay, so let's make an assembly of one of the wheels. So we're going to create a new assembly. And we're going to insert the wheel pulley. And we're going to insert the wheel from GoBuilda. Okay, now let's make a revolute mate with this hole right here. Not getting quite the alignment that I want from the secondary axis. So we'll hit solve there, and then I can actually create another revolute mate. This hole, that's not what I wanted. Solve that. Okay, so revolute lets it still rotate. So we put one, it's like putting a revolute mate here is like putting one screw in, and then it can still rotate into place for the second one. Once there's two revolute mates in different spots, then it's not going to be able to spin anymore. All right, and let's put some screws in there. So we're going to insert now standard content. DIN, bolts and screws, socket head screws, M4 by, I think we need 12 millimeters here. So if I click the circle there and I hit insert, it'll put it in right for me. Let's see if it pokes through the back. It does not. So we need a longer screw. Let's try this again. Insert, DIN bolts and screws, socket head screws, hex socket head, DIN 912, M4 by 30, stainless steel. Let's click where we want to insert it first. And then it does all the work for us. Insert, insert, and insert. Now we flip it over and we're going to put nuts on those. M4. Insert. For these guys. Okay, so there's two more things that we need to add to this wheel assembly. They're bearings, one bearing for each side. So we're going to insert, and we're going to go back to our Go Build a Motion bearings. And we'll go to ball bearings, flanged ball bearings, and we're going to take a 1611 series flanged ball bearing, 8 millimeter Rex inner diameter by 14 millimeter outer diameter. And we're going to insert that as an assembly. This one is a Rev Robotics FTC. This one here. Okay. And we're going to go ahead and insert these bearings into our assembly. So put a fastened mate back of this thicker one. And that will go on the front of this. Good, accept. Okay, so we got a bearing on both sides now to support the wheel. That's good. And I have to leave this fastened connector. And then we're going to right click on our pulley and we're going to select fix, which will now not allow it to move. And since the other things in the assembly are assembled to that, they won't move either. And now at this point, we're going to make two different variants of this. We're going to make a right slant and a left slant variant. So we're going to go over here to the right hand side and hit configuration panel. Configure assembly, We're going to call the default left slant, and then we'll also make a right slant version. All right, now over here it shows us that we're currently working on the left slant version. So we're going to go ahead and insert our right slant wheel. Let's go back to our Go Build a library. And we'll pick the right slant wheel and insert that here. Okay. And now select this, and configure assembly features. Select instances or mates to configure. So I'm going to select both of the mechanism wheels in my tree here, and check the unsuppressed thing there. So for the left slant version, I am going to unsuppress the left slant wheel and suppress the right slant wheel. And for the right slant version, I'm going to unsuppress the left slant and suppress the right slant. All right, so now I want to work on the right slant version. So I'm going to select that here, and I just got to make my connections, my mates here. Let's go with Revolute, and I'll pick the top surface of this and the bottom surface of our bearing. Reorient secondary axis. Doesn't get me what I want, so I'm going to have to just accept it as is and set another revolute. Oh, it did make it. It did assemble it the way I want it. Okay, so perfect. All right, so that's my right slant configuration. That's my left slant configuration. So we're done with our wheel assemblies. Now we're going to go back into our left side assembly. Delete. And delete. And we're going to reinsert those as the assembly. In our current document, we're going to select assemblies, wheel assembly left slant, insert, and then wheel assembly right slant, insert. So these are on top of each other right now. Let's separate them out, and we'll take this left slant wheel and put it in the front, and the right slant wheel and put it in the back. And we're going to use a revolute mate here. I'll select the back of this bearing. Not this nut, I don't want that. I'll select the back surface of this. Solve so we can see what it looks like. And I put it in place, but you see it's poking through, so we need to add an offset. It's going to be a Z offset. That went in the wrong direction. Let's go the other direction, minus 10 millimeters. Solve. That's not enough. We need a little bit more. Minus 14. Solve that. That looks pretty good. It's got clearance at the front and clearance at the back. So we'll try that for now. I didn't take these nuts with it. Let's get this fixed. Fastened mate. center of this bearing where it came off of. And then we're going to fasten each of these bolts on the back here, or nuts rather. Okay, some things broke here a little bit. We gotta put these two back on. Last nut. All right, and then let's put this as a revolute mate on the shaft that it goes on. So we'll select the back surface of this. Oh, that didn't work. Sometimes you have to select a different one for it to orient correctly, a different part of this of the surface or of the edge. So we'll do our offset of -14 in the Z that we did before. Hit OK. Our wheels are in place. Now we just got to fix this plate that came off. So let's do this with a fastened mate. Okay. So that looks good. And now we're going to bring in our motors. So we'll go back to other documents and our Go Build a Library, Motion, Motors, Yellow Jacket, and we're using the 5203 series 312 RPM. This one here, and I'll insert it as an assembly. Take this back plate and right click and fix. Now the assembly, the rest of the assembly won't move, only the motor will move when I fix it. So we'll do a fastened mate again. Okay, that looks good. Let's copy it. Copy and Control V to paste. And then we'll do a fastened mate between that hole and that hole. Solve, accept. Get it from the front. Okay, looks good. Hide all mate connectors. There we go. Just a little easier to see. And last thing we need to do here is put some screws in. So we'll insert standard content and we'll use DIN bolts and screws, socket head screws, M4 by 8. And I will use these for all the screws that connect our front and back plate. So I'll do that once here, and then, okay, let's just go and insert them one by one then. I'll select each of these holes in the front face. It automatically makes a fastened mate when you do it this, when you insert this way. See the fastened mate is going up 21, 22, 23 each time I insert a new one. All right, cool. And now on the back plate, and then I'll make a fastened mate and try and replicate it for the back. Okay, so now let's select this one and let's replicate. And we will match edges on face. There we go. Had too many things selected for instances. And you see that automatically put a screw in all of the holes on that side of the plate, on that face. All right, so we need one more type of screw here. We need a countersunk screw on the front. Cross recess head screw. And these are also M4 by 8 millimeters. And so I'll insert one of these here. Then I'll make a fastened mate. Flip the primary axis and OK. Now let's try and replicate that one. So a lot faster than putting them in individually if we do it through replicate. Two more to go. One there and one there. And we've got this extra screw floating here that I accidentally inserted. Delete that. And then let's go back to our full view drawing. And let's hide all of our mate connectors. So since we inserted these wheel assemblies as with revolute mates, you can see you can turn the individual wheels there, but you can also turn the entire wheel. So you can check out clearances and things. If we look from the bottom or the top, grab the wheel and spin it. And that looks close, but I think it'll be fine. And this one lost a mate somehow. So let's fix that. Let's add revolute mate here to, that's going to be right there. Solve. Correct. Okay. So we should be able to now grab this one also and spin it around, and should be able to check all of our clearances and things. There's one more thing that this needs though, connection between the motor and the pulley and the wheels. So we need to insert some pulleys on the motors, and then we need to insert belts to connect the motors to the wheels. So let's do that now. Okay, so in motion for this is go build the parts, and we're going to use timing belts and pulleys, 5mm HDD timing belts and pulleys. So we're going to use pulleys, and this is a 3417 5mm HTD timing belt pulley with a 8mm Rex bore and 24 teeth. That's what we would like to use here. So let's click that. And it's not an assembly, it's just a part. So we'll go ahead and insert it. And accept. All right, now we gotta fix that onto this shaft. So let's make another revolute mate here so this can spin around as well. Oh, I'm sorry, since this is actually, it's a hex shaft, so this should be fastened, not revolute. And I'm trying to get the center of this face. Now we gotta like look inside here and shift to the center of that face. Flip the primary axis until it's on the correct side, and then we also have to offset it because the surface that we're mating to there is a little bit inset. So let's try -Z is going to go in the direction we want. And what we're trying to do here is actually, whoops, line up these two pulleys on the wheel and on the motor. That looks pretty close. We'll double check it again when we get the belt on. That's pretty close. So let's go with that. And then let's see if we can replicate this one. This is going to be the 31.417 and match individual edges. Let's go inside here. Didn't work. Try again. Replicate the 3417. Match edges on face. There we go. And since we're replicating it, automatically set our offset the same correctly. So we're good there. All right, and so now we need pulleys. And in order to figure out what size pulley we need, we'll use a pulley calculator. So let's go to build a pulley calculator. 5mm HTG timing belt. So our pulleys are both 24 teeth. We need to enter the center to center distance, and that'll tell us how many teeth we should put on the pulley, or put on the belt rather. So we can do our center to center distance if we go back to the left side plates drawing. Let's look at it from the front, and we're going to look at the let's look at the guide sketch. So for the left one, we've got 77.7 is our center to center distance from the center of the motor to the center of the wheel. And for the right one, it's 140 millimeters from the center of the pulley to the center of the wheel. So let's go put that into here. 77.7 millimeters for the left one, so we need 55 teeth. And then for the right one, we put in 140 to center distance, and we get 80 teeth. Okay, so go back to our left side assembly, and we're going to insert a 55 tooth belt here and an 80 tooth belt here. All right, so we're going to use a belt generator tool, which we'll put a link in the YouTube notes so that you can get to that. We will go to belt generator V2mm. We're going to use a 5mm HTD belt, a thickness of 9 millimeters, which is one of the standard thicknesses for the belts. Center to center was 77.7 millimeters. Pulley teeth was 24 and 24. And the total teeth was 55. We'll generate that. And now insert here. And then let's go ahead and generate our other belt, which is 140 millimeters center to center. Same number of teeth on each pulley, 24 and 24, but now it's an 80 tooth belt. So we'll generate that. And insert. Okay. So now we're going to use a revolute mate, and we're going to select the center of the right end here. We're going to mate that. To this face on the back pulley, we'll offset it so that it's centered on the pulley. Minus, let's try 5 millimeters offset. And that's pretty much centered. Okay, so that's pretty much centered on that pulley. Now we need to get it around this pulley. I guess we need to change that to a fastened joint. And now we can rotate around Z. And we're going to figure out the right rotation angle here until it lines up perfectly with the green pulley. Minus 34.5 will be about right. Seeing about the same amount of belt above and below the pulley. Okay, so now we'll do the same thing with the 80 tooth belt on the other side. We're going to make a fastened mate here to the surface of this pulley. And we're going to offset by, I think it was 5 millimeters on the other one too. So that's good. And then we got to get the offset angle right. Rotate around X, I'm sorry, Z. Is getting us pretty close. I still see a little more black above than below, so 25 looks like it's a little too high. 24.5 looks like it's a little too low. 24.7 looks like just right. So we have one full side of our driving base complete. Now we just need to create the other side. And we'll do that by right-clicking the left side assembly and hitting duplicate. And let's rename this right side assembly. Get rid of the copy part. Show our mates. I want to move this if I can. What we're going to do is take this front plate, move it to the other side of the back plate, and then start reassembling things. So we have a lot of mates here. We're going to basically we'll just delete all of these mates. Now we can move pieces around. And so I'll put that on the other side. And now I will new fastened mate for this spacer. And the other end of the spacer as well, to kind of get things situated first. Solve. Oh, I got that first end, but not the second end. Okay. There we go. Go back to the front. And let's move these motors out of the way temporarily. Move the wheels out of the way temporarily. I'm going to fix these connectors for this wheel. Or the bearing and the nuts that did not get correctly fastened in that assembly. So let's do another fastened mate and get the rest of these nuts on there. Now let's move this axle over to the other side. We'll make a fastened mate here. Front face. And let's go ahead and replicate this one. we go. Gotta get the right mate to match. And then let's replicate the axle. Match individual edges. There we go. Now let's move this one over. Move this one over. And let's actually rotate this one. So let's look at this from the back. All right. And this guy, we want to rotate full 180 degrees. Okay, so now it's facing the correct way. It's a little easier to line up. And let's do a fastened mate here. For the small spacer for our motor plate. And then we can replicate that one. Match individual edges, and we'll put one here. And here. And here. Okay, and then we need to fasten our motor plate to these standoffs. Make sure I got that correct face. And put that with this one here. Look at it from the back again, and then keep things from moving around. At this point, I'll select the back plate again, and I will fix that. Oh, it's already fixed. Good. Don't need to fix that. All right, so we need to put our motors in next. So let's create another fastened mate. And we'll do center of this screw hole. Two. That one there. Flip primary axis. Solve. Make sure it's in the right spot. Yes. And then the same thing with this motor. Solve. There we go. Okay, we're getting there. All right, so now let's put the wheels in place. So we'll do revolute mate. And we'll select the back of the bearing here. And now that one is going to go on this side. Just Doesn't want to go on there, right? Let's try this. There we go. All right. Flip primary axis and now offset. Oops, minus 14, not minus 1,000, 1,400. Solve. That looks right. And now this one. Let's do that the same way. Go through the hole here. Well, actually it's hard to see because of the screw. See if we can get it to seat correctly. There we go. And we'll offset also by minus 14 millimeters. And now let's bring the belts where they're supposed to go. Let's make a fastened mate of the belt. Center of the belt. Offset. We need our bearings too here. Well, we can go ahead and get this belt set. Rotate about Z. I don't remember how much we rotated it before. We could go back and check. Or we could just try it like this again. There we go. We're going to have to offset that so that it's on the pulley. We'll offset in the Z. That looks pretty good. Okay, and now the other belt. We'll fasten that on here as well. And we're going to have to offset that. And we're going to have to rotate it a little bit. It's looking pretty good. All right, and then we need to get our screws back in, and we need to get these center pulleys in, which I don't know where they went. I'm not sure why I don't have the center pulleys that anymore. And then the other pulley. And let's set this pulley. Okay, and we'll offset it in the Z a little bit more. That's pretty good. Delete these replicates that have errors. Didn't rebuild right. So let's replicate this one again. There we go. Let's see this one. 14, 13. I think that's the right one. That looks pretty good. All right, so we have our right side assembly and we have our left side assembly. That's the left side and the right side. So then last thing we need to do is assemble them together with some connector pieces. So on the right side assembly, actually, we still need to put the screws back in. So let's do that. We've got all these screws here. I'm going to delete most of them. And let's make this a fastened mate here. And let's replicate that if we can. Okay, so we got screws all in the front. And let's match the edges on the back plate too. And we got screws all in the back. There's an extra screw here. Delete that guy. And then these two screws are extra also. I'm going to delete these extra replicates. There's another extra screw there. And then we need to put this screw in the front of the motor plate. And flip our primary axis so it's going the right way in. Okay. Now we're going to replicate that one. Match edges on face. let's hide our pulleys for a minute. I'm having trouble hiding it, so I'll just poke behind it and select the other surfaces to find the screws in. There we go. All right. And unhide our pulley. And the right side assembly is now done. Okay, so now we have this right side assembly and we have this left side assembly, and we're going to put them together into one drive base. We need to make another assembly, which is our full assembly. There we go. All right, let's start with our U channels and these dual block mounts. Left side U channel, 10 hole. Okay, let's create a fastened mate here. And let's rotate secondary axis like that. And we'll copy and paste this guy. So let's leave our fastened command, Control C, Control V, make a new fastened mate. That's good. And let's put in some screws here. Button head screw, M8, and let's go with 8. Screw this to, screw these dual mounts to the channel with socket head screws. Okay. And then let's duplicate this. Control C, Control V. Let's take this second one, move it up here, and we'll rotate it 180 degrees. We're going to place it precisely pretty soon, in a minute. Okay, so now we're going to stick that to our left side assembly and our right side assembly. So we'll insert parts and assemblies from the current document, assemblies, and we'll insert the left side assembly once, and we'll We'll insert the right side assembly once. Okay, and now we're going to try and assemble this all together. And this screw is extra. Don't need that screw there. We're going to add that screw when we go in and assemble them all together. So let's go real quick to our right side assembly and delete those two screws. We can match individual edges here instead of all the edges on the face. And same thing on the front. Okay, let's do the same thing now with the left side assembly. Need to get rid of these two, but it is part of replicate 5. So we'll change that to match individual edges, and we'll do it one by one. Put these screws in the holes where we need them, and leave them out of these two holes where we don't want them. Okay. So we'll go back to our full drive base assembly. And now these screws have been removed from those two wheels. Oh, looks like we missed one in one of our assemblies. Not the right side, must be the left side. Back to our full drive base. And now I notice also we've got holes to match this U channel on one side but not the other. So we're going to go and add that into the other side, or add the other set of holes onto, we'll go to the left side plates. Let's look at the back here. This is the inner plate sketch. We're going to modify that, and we're going to basically copy these two and paste them over here. And we can do that with a mirror command. Mirror them around here and up right about there. Let's see how that looks like. Put the full drive base together. So we're going to do another fastened mate here, and we'll go from this one to that one. Let's hit solve to see what it actually looks like, and we want to change the primary axis, solve it again, rotate the secondary axis and solve it, and that's how I want it. Okay. So let's do the same thing with this one. All right. See which way it's pointed. Change the primary axis. Now it's pointed out, but it's rotated wrong. And that's how I'd like it. So we'll hit OK. And now I need to create a new fastened mate here to attach the other side of the drive base. Right here. That looks good. That's our full drive base. We just got to put screws in to hold it together. So let's go with let's go with button head screws. Eight millimeter again from the inside here. And you can see what I mean. It's a little bit tight in there. Yeah, that's going to interfere. So that's something we're going to want to modify. So it doesn't interfere there. Let's go ahead and put it in for now, and then we'll go back and see if we can modify it. So that it doesn't interfere with that wheel. All right, so if we spin this wheel, let's go ahead and fix one of these members here. Now we'll try and spin this wheel. Oops. That didn't work the way I wanted it to. If I spin that wheel, it's going to hit that screw. So what are our options? We can move the screws more towards the middle. Move this out. If we move this member closer to this axle, then I think it won't make any contact. So let's go and modify that. We'll look at that mirror on the inner plate sketch. So these two space them out a little bit more. 8 millimeters is the standard for GoBuilda. So if we try and put it on that pitch, We want to be at 128 or 136. Let's take another look at our drive base. Oh, it's still not quite there. Let's move both of them over, perhaps. Both of those cross members. I want to delete that mirror constraint. Okay. Let's delete this mirror constraint too, and instead make these two vertically aligned. Those two horizontally aligned. Those two horizontally aligned. All right, and now we'll go back to our full drive base and see what we got. It's still not quite as far in as I would like. So let's move both of these a little to the right. And see what that looks like. Okay. I think that's going to be safe and not interfere anymore with the wheels. So I think I'm happy with that. Zoom to fit. Hide all mates. There we go. And I think we're done. Thanks for staying with me through this whole tutorial. I hope you learned something. And thank you to Tristan for the original tutorial, which we'll link in the YouTube notes below the video. So you can go check his video out and his channel out as well.